Hi, welcome to this video. I'm Sergio. I'm a computer vision developer and consultant and course instructor, and I help companies, freelancers, and students to easily and efficiently build computer vision software. This is the second video of this series, Computer Vision with Keras, where for the first time we're going to build a model. There are two ways to build a model with Keras. One is with the functional API, which is the one that we are going to see today. And the second is a sequential model. We will not get into the details right now. We're just going to see with the basic and understand how we can easily build a model. It is going to be very easy, so even if you're a complete beginner, but make sure that you follow the first video where I show you the installation, so you should have at least Python, Keras, and OpenCV. If you're ready, let's go. Now, the first thing that we are going to do is to load an image. I have this image, which is redpanda.jpg, which I'm going to load with OpenCV. I recommend either you use your own image, or if you want to download the files, source code and images, I'm going to put the link on the blog. So you check on the description, there is the link to the blog, and inside the blog post, you can download all the files. Redpanda.jpg. Let's load this image with OpenCV. I have the redpanda.jpg inside the same folder with the Python code. And so let's do that. If you just are new with PyCharm, on the project, you just create, you click on the folder, right here, new Python file, and then you create a new Python file, load image. I have that one already, so I get an error, but that's how you do it. Now let's import CV2, which is OpenCV, which you should have already installed. And let's load this image. img equals cv2.im read. We're going to read what? We're going to read red underscore panda.jpg. Now, to make sure that we're loading the image correctly, we are going to show this image. cv2.im show. The title of the window can be anything, red panda, let's say. And then what do we want to display? We want to say display img, which is the image that we just loaded. Now, what is happening when you run this basic code? A Windows opens and it closes very soon because the Python is executing. There is nothing else to execute, so it finishes. So in order to display an image, we need to put a wait key event, cv2.wait key 0. So we keep this image on hold. This is how we load an image. We're now talking about computer vision with Keras, so we will go slowly in the next video of this series into deep neural networks. And so now for the basic, we need to understand when we have an image, how do we pass this image into the neural network? When you see the example of neural networks online, usually you see these two types of images. This one, where we see input layer, then many layers in the middle, and then output layer, where input layer is, of course, the image, because in this case, we're working with images. If it was another thing like audio processing, it would be the audio and so on. In the middle, there are different type of layers which will process somehow this image, and then the output layer, which is going to give us the result. So if the input layer is an image, the output layer could be, for example, in object detection, the bounding box, so surrounding the objects in this image with a box. If it's image classification, the output layer could contain information like is in this image a dog, is in this image a cat. It could be segmentation and so on. So this is one type that you see, and this is the other type. This is the architecture of the object detection model YOLO version 1, where we see the architecture of different layers, where we start with the input layer, this one, and then many layers that we will see in another video, like more in depth, but now just to give you an idea, and then finally the output layer. Let's now do the same with Keras. Let's start by creating a very simple layer, the input layer. To do that, we say, okay, Keras input layer. Let's just put a comment. Then we need, of course, to import Keras from TensorFlow import Keras, or we can just import Keras. You could also import Keras if you have it installed this way. As long as you don't see any error right here, it's good to go. So if I do import Keras, it runs and I don't see any error, it means that the installation is correct and it's loading correct. So I'm just waiting, import Keras, it's working. So we import Keras. Now let's create an input layer. The input layer is the one that takes the image. Input layer equals Keras dot input. So very easy. This is our input layer that we have right now. There is, of course, something more that that we need to work and understand what to put in this input layer. The input layer takes some information, and normally we need to understand how big is this information. So what is the image? To understand what is the image, we can go and print EMG. So for the moment, I'm going to comment Keras just because it's faster to load. If we load Keras, it's a bit slower. So that's why I'm putting a comment right now. When I print the image, I see a lot of numbers. What are these numbers? These are arrays where each pixel is defined by different values. So we have, for example, 49, 80, 83, the first value. What are these values? Each one of these three numbers, so this is an array containing three numbers, represent the color of a single pixel in the BGR format. So this is defining how that specific pixel is colored. So 49 of blue, 80 of green, and 83 of red from a scale that goes from 0 to 255, where 0 is the absence of the color and 255 is the maximum of the color. So each pixel is defined by this. Of course, now we have just a sample. We cannot print, so there is no space to print. So where there are dots right here, like we have thousands of these lines, but it's just not showing them. So the image can be displayed with something like this. So if this is the image, and let's see in this specific case the size of this image. We can also see the size of the image. If I print emg.shape, let's do that. emg.shape, we're going to have 1004, 1280, and then we have 3. In this case, 1004 are the rows, which are also the height of the image. 1280 is the width or the columns of the image. 3 is the channel. Let me give you an example right here. We have 1004 per 1280. It means that we have 1004 rows like this. So this is the first row, let's say. This is the second row. This is the third row, and we have 1004 of them. And we have 1280 columns. So this is the first column. This is the second column, third column, and so on for all the image, where each pixel is represented by 3 values. That's why we have 3 channels. Keep in mind that this is the opposite of what you see normal in the size of the image. So when you see image size 1280 by 720 is first the width and second is the height. In this case, we have the opposite. So keep in mind that this is always the opposite. First we have the rows and then the columns. First height and then width. So this is the image shape. Now I want to simplify this. How can we simplify an image? We have a color image. If we want, for example, to perform object detection, right here we have a red panda. Okay, if it's red, of course, we need also the color. Let's say that we want to detect panda, not red panda. We can avoid using the colors. So this is going to simplify a lot the image because each single pixel will be represented by only one number instead of 3 numbers. And so how can I do that? I'm going to load now the image into a grayscale format. Instead of loading just a red panda, we're going to load cv2.im read grayscale. And if I print now the image, so let's now show the image. This is the red panda grayscale format. And now you see, instead of having 3 values for each pixel, we have just one value, 1004 by 1280. This is the image that we want to process with a neural network. So this will be the input of the image, the input that is represented in this case, so input layer. How many input, I mean, the input layer is 1, but how many parameters do we need in the input layer? Let's now remove the comment from Keras and an input layer. The parameters are defined by the shape of the image, of course. So we can define Keras input, we can define the shape, and the shape is equal to, we have first the 1004 and then 1280, which is the shape of the image that I have. So if I compare image shape, img shape, so I'm now printing image shape, which is img.shape, and also we're going to print the shape of the layer, print input, let's say layer input layer shape will be input layer dot shape, and then image shape. Let's now run this one and let's see what we get. This is our result. We have EMG shape 1004, 1280, and the same is for input layer shape. Of course, if we change the size of the image, like if we load an image with a different size, this will be different. So we want this to be dynamic, and we take the value from the image that we're loading instead of define a specific value. Of course, when we will go more in depth into this, we will see that images are usually resized to a specific size and so on. But now, just for the matter of understanding how the input networks work, let's do it this way. We have the rows, we have the columns that are equals to emg.shape. So the rows and columns, which is exactly the same as height and width. So you could say height, so height and width, like this. We have input layer. How does now this work? If you see we have input layer, then we can add, of course, layers in the middle. With the functional API, the way to add new layers is this one. We define a layer which we can call however we want, layer 1, for example. Now there are different types of layers. We have, for example, the dense layer, the max pooling layer, the convolutional layers. It's something that we'll get more in depth later. So now we're going with the basic dense layers. So let's now import the layers type. From keras.layers, let's import dense. And we now define this layer, dense layer. And we can now define how many neurons do we want in the dense layer. For example, when we see this image right here, each of these circles is representing a neuron. It will mean in this case that we have how many input, what is the input shape right here? 1, 2, 3, 4, 5, 6, 7, 8 of input shape. What is the first layer size? 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this case, representing this image, we'll have dense layer with size of 9. We now don't really care about the size. We just want to show how to put multiple layers together. So I'm putting a standard 64. Now that we have the second layer, we need to connect this one with the input. So in order to do this, once we define layer 1, we go and put the input right here, input layer this way. Very easy. So now we have the input layer connected with the first layer, 64 neurons. We can put a second layer, layer 2 equals, let's say, dense 32. It doesn't really matter the values. We don't now care about what these layers are doing. It's not our goal right now. Let's just create the network. Now, how do we connect layer 2 with layer 1? Exactly the same. We define the layer here, layer type, how many neurons in the layer, and then what is the connection? We connect this with layer 1. Let's now conclude this model defining an output, so we have input, layer 1, layer 2. In this image is showing layer 3. Now we're just going straight to the output. So now we connect layer 2 with an output. So again, we define an output with dense. Let's say that we want to output only two things, two values. And we connect this one with layer 2. This is now the structure of our model. Our model is not ready yet because we need to now to the final model. So we can say that this is Keras model structure. There is some typo here, structure. And now define model equals Keras dot model. And in the model, we need to define the inputs, which is the input layer right here. Output equals output. And that's all. That's our model ready. Now, let's see a summary of this model to make sure to see first the structure and to make sure that we're not getting any error and to see that this is working. And we can do this easily by typing model.summary. If we run this, we're going to get now the structure of the model. So first, let's close this image and let's run this one. This is the structure of our model. We have an input layer with shape 1004, 1020, this is the height of the image. This is the width of the image. We see a value which says none. This none is referring to the batch size. So how many images with this size we can pass right here. We don't have anything specific related to this. So that's why we have none. And that's fine. We don't care about that right now. We're just seeing the structure. So we have the input layer, dense first layer, second layer, and output layer. Now things are not very super organized, or like we don't have like the names, or we don't have anything fancy about this. Even with the image, now we cannot do much. There will be much more to it to understand how to make the training, how to structure better the layers, giving names to the layers, and so on. This is building a model using the functional API. So I told you at the beginning there are two ways, the sequential model and the functional API. The functional API is somehow less intuitive. So the one that we use today is the least intuitive, but it allows you more freedom to create more complex things when you want, for example, you want to have multiple inputs, you want to have multiple outputs, also something in the middle of the model. When we use the sequential model, everything needs to be in a sequence from the input to the output, so there is not much freedom, but at least things in the sequential model will be more organized and more intuitive. So it depends on what you need to do. Mostly we will use the sequential model, but it's good that you know that both way exist. This is all for this video. I recommend to try to play with these values to add more layers and see if you're able to do that. This is all for this video. See you in the next one.